Now that we have a little bit of an understanding of how we can work and edit our curves, let's use them to physically create some geometry. This is where the curve system really comes into play, because we can use these wonderful, smooth, organic shapes to create geometry, which is really kind of cool. And this geometry can be edited at any time while the modifiers and the curves are still participants of our 3D scene. Let me show you what I'm talking about. For our lab assignment, we're going to be building this cool kind of ship's wheel, if you will, from like a pirate ship, which is cool. This is where they physically drive the ship. And we're going to make almost all of this with curves, or all the geometry is going to be created from a curve. And we're going to start off by looking at how we're going to create this little pedestal. And this pedestal is really one of the support beams for the entire wheel itself, and it's pretty neat. And if you look carefully here, it's got these wonderful, smooth, kind of flowing curves as it goes from the top to the bottom. This would be a little bit of a challenge, and it would require some effort, let's put it that way, to create using our traditional 3D modeling tools. However, this is the perfect application of our curves, because we can very quickly go in and create the profile of this shape and then use a modifier to transform it into actual 3D geometry. So let's go ahead and get that process started. It's really a whole lot of fun. Pardon the dust. I've already imported in the reference image that I've supplied to you inside of our assignment sheet, and I'm just going to lower its opacity. That way I can see both the pedestal, the shape I'm trying to make, and the curve at the exact same time. So Shift A, we're going to add in a Bezier curve. There it is, right there at the origin of our three-dimensional scene, and immediately let's go into edit mode. That way we can start working with all of the control points of our curve. Now, as a habit, and I think this is a good practice to get into, the first few that I have, the first few control points that I have on my curve, I almost always change their handle type to vector. That way it's just a little bit easier and a whole lot faster for me to go in and start creating these shapes. Excuse me, hit the wrong button. All right, so the first thing that we need to do is that we need to start getting these points into position. Now, what's neat about this whole system is that we're not going to create the entire pedestal. We're only going to create the profile shape, so kind of like half of it, if you will. They'll just, from the center of the object out to that outside edge and then all the way up. So we need to have a dot, a control point, right in the middle of the x-axis, and that's job number one. I'm going to hit the G key and then immediately hit the X key to constrain my movement along the x-axis. It's really important that this dot, that boundary control point, be in the middle of the x-axis, right there snapped to the grid. So this is a perfect opportunity to turn on our snapping tools. And of course, naturally, you can find our snapping tools way up here. We're going to use some grid snapping, okay, also known as increment snapping, here inside of Blender. And to ensure that our dots get snapped to the actual visible grid lines, let's turn on absolute grid snap and then activate the snapping engine by hitting the magnet. Now, when I go in, check it out, hit the G key, hit the X key, now it's snapping that point to the grid. Boom, right there, that's what I want. Okay, let's grab our friend over here. And once again, same thing. I don't need my snapping system on anymore. Shift-Tab activates and deactivates our snapping system. And now, I'm just gonna move it, excuse me, I didn't grab all those pieces. Grab X. I want to move that dot so it's right there on the corner of the pedestal. Let's use the extrusion tool to start growing our curve upwards. So E to pull out a new dot. And I think this is, hopefully you'll start to see the power of these vector tool handles, because it allows us to quickly block out some shapes. Now, when we're blocking out some shapes, it might be important, and it is kind of important, that this be a perfect 90-degree angle right in here. And this is where the snapping system comes back into play again. Previously, we used the grid snap. Well, now I want to use some vertex snapping. I want to snap to some existing points. If we go back into our snapping palette, we want to use vertex snapping. And I'm going to snap with the active object. That ensures that what's selected is going to get snapped to another point. Not the closest point, the active point. Not the center of whatever's selected, the active. It just gives me the most control and confidence that the points are truly snapping together. All right, let's go back in here now. I'm going to hit Shift-Tab to activate my snap system. And now I can start, firing off the grab tool. However, let's make sure all 3 points are selected. The snap system really kind of doesn't work too well when you're using just the grab tool. What I like to use is the actual transform location tool. So this would be the move tool, if you will. So the keyboard shortcut for that is spacebar G. And what we gain here are these tool handles. And I'm going to see if I can do this. Let's see if I can zoom in a little bit so you guys can see, because I recognize these dots are pretty hard to see. I want to have this control point, just its X location, be snapped to its friend down over here. I want it to share its exact same location in the X axis. So I'm going to grab the arrow, and because I got my vertex snap on, it doesn't matter where I put my cursor up and down. It's only ever going to move that point along the X axis, which frees my cursor, my mouse cursor, to move down to this point over here. And the moment I hover my cursor on that point, boom, it snaps, which is pretty cool. So we've constrained the snap to a singular axis. Let's do that one more time, because we're going to be doing this a lot. I'm going to turn the snap system on, the vertex snapping. I'm going to grab the axis that I want to move this dot along, and I'm going to put my cursor on the location that I want to send it to, which happens to be this guy down there. All right, let's move on. I'm going to hit just get out, Shift Tab of my system here, or my snapping system for a second, and we'll start creating the curve for this little inset in here, which is pretty neat. Now, when it comes to making curves, one of the things I've learned is that curves are really defined by the beginning of the curve, or we define a curve by the beginning and the end of the actual curve itself. Well, the beginning is here, the end is over there. I need to define the beginning and the end with a point, okay? So this is what I'm going to do. Now that I look a little bit more closely at, I think I'm going to extrude this along the X axis. There we go. And the handles are very small, and for that I do apologize. Let me see if I can zoom in. Yeah, there we go. That's what I have, just a little bit of a flat edge there. And now I'm going to extrude this point again, just vertically. So don't want to delete. E to extrude, and then I'm going to hold down the Z key to have it go up and down. Maybe somewhere right around there. There we go. Now it looks like the end point is maybe a little bit like I missed it. Somewhere right around in there. Yeah. Now let's do it one more time. E, Z to go immediately up. Now we want to have this point and this point be in the exact same location along the x-axis to ensure that we get a nice consistent curve. With that done, with the location of our verts created, let's change the tangent handle so we can start physically creating the curve itself. Now the tangent handle we initially chose has been perpetuated every time that we've extruded it, so it's kind of keeping all of that same handle type every time we hit the E key. Well, I want this one to be free. Let's go ahead and change it, because that gives me the functionality of moving these handle types. I want this one to be free as well, because now I can grab that handle and start crafting and customizing where I want my curve to be. And this is where it gets kind of fun. Excuse me, hit the wrong key. And I'm just doing this to the picture. Yeah, something like this. One of the things that I've learned about working with curves is that we want to have, on a curve like this, we don't want to have the handle be above the dot that it's going into, because then it's going to make kind of a weird undercut on the curve. Let's see if I can get, yeah. See how the curve slopes down into the point? That's not exactly what I want in this moment. So I want to keep the handle kind of parallel, perpendicular, something like that. Now, an adjustment of the slope here, the weight, excuse me, will probably get me what I'm after. Something like that. Yeah, I'm super close. I can sit in here and kind of monkey with it all day. There we go. I think I've nailed it. We're going to do the same thing on this one over here. Grab its tangent handle. I'm going to make this kind of parallel. Let's see what that does for me. Once again, change the handle type back to free, so I have complete control over it. Yeah, something like that, which is working out just quite wonderfully, I think. Yeah. The cool thing about working with these curves is that they're editable at any time. I'm already noticing some small little changes that I want to make, and I can do that at any point with these curves just by going back into edit mode and changing the location of these dots. Let's keep cruising up here. I'm going to extrude this last one out along the x-axis, somewhere right around there. And now we have a big soft curve in here. So I think I want to have the next point be right there. This is where we have to kind of manage our tangent handles to a certain degree. And sometimes managing your tangent handles is a whole lot easier when you have more than one point inside the scene itself. And that's what I've done here. I've just gone in and, yep, I think I got things a little messed up. And if this happens, just change your handle type back to vector, and that'll get everything back to where you want it to be. Here's the cool thing. I didn't mention this earlier, but the neat thing about working with the vector handles that it gets all the tangent handles pointed in the right direction, but that doesn't mean you can't go in and move them, which is pretty cool. It automatically changes the handle type back to free. And one of the cool things about working inside a Blender is that each handle can have its own handle type. One side can be free, one side can be vector, which allows us to create some wonderful straight lines as you see there. All right, let's get this same thing working back up here. I want this handle to be vector, so it points at that friend. Same with this one. I want this, I'm gonna go back to this selection tool. I want this one to be vector, so it points in a straight line to that dot right there. But I want this guy at the top to be free. That way I can go in and just make a couple small adjustments. Something like that. Okay, almost done. Almost done. Let's see if we can get this going a little bit faster here. And I'm just going to do this. I'm going to just block out my shape. Just quickly. I'm trying to find the start and the end of all of these curves. Something like that. And of course, we need to extrude along the x-axis. And I need that one right back down there in the center. And this is what we have. Ta-da! Looking pretty good. Now, of course, we still have some work in here that we need to do, but just adjusting the tangency of our handles and the handle types will get us to where we want to be. Now, this final one, I'm going to intentionally leave it away from the boundary, just so you can see what happens when we start adding in the last step, which is the part where we physically get to take this two-dimensional shape and make it into a three-dimensional piece of geometry. I want to deactivate my reference image just for a moment, because at this point it's really super important to ensure that all of the control points of our profile curve are perfectly in a two-dimensional straight line. Now from the front here, looks good, but we want to double check. I'm going to look at my scene from the top, and yeah, that's what I'm expecting and hoping to see. All the dots that create that profile shape are in a perfectly straight line. They're on a plane. If yours are not, just grab them, snap them to the grid. We want them to look just like this. That way, when we add what's called the screw modifier into the mix here, everything is going to be transformed into a piece of 3D geometry correctly. Let's go into object mode real fast and add in the modifier that's going to allow us to take this two-dimensional profile and transform it into a three-dimensional curve, and it's pretty cool. It happens at an object level. This is, in fact, a modifier. So we'll go into the wrench area of our tool properties, and we're going to add in what's called the screw modifier, okay? The screw modifier is going to, it can do a number of different things, but in this particular moment, it's going to work with the curve and transform that two-dimensional path into a piece of three-dimensional geometry. Let's go ahead and activate it, and voila, there it is. It's taken that shape and it's made it into actual geometry, which is pretty cool. If you look at the properties over here, there's a couple things that you just may want to double check. First and foremost, the angle should be 360 degrees. However, if we change this to like, oh, I don't know. Yeah, how cool is that? 207. We don't have to sweep the path in an entire 360 degrees. We can do a fraction of it. Maybe we only want a half circle. It's 180 degrees. And we got going. Now, the actual screw settings itself, this is how you would actually physically make like the threads on a screw and then repeat that process over and over and over again. For our case, what we're doing, we want to leave this at 0. Same with the iterations, leave those at the default. The axis is going to determine which direction that we want to have this be swept around. We want it to be along the vertical axis, which is the y-axis, but maybe for that ship's handle, we choose the x-axis, which might be pretty cool. Now, the steps viewport, this is going to determine the quality. So at render, it's going to be at 16. Right now, we're seeing 16. So this is what it's going to look like when we render. If we wanted to render of higher resolution, just increase this like 32. So this is one of the benefits of working with these modifiers, is that we can have one setting for the viewport an optimized setting for a real-time kind of construction environment, then a higher quality when we hit that magic render button. Now, the other thing that we want to double check out is this normals, because it's very common that the normals, the directions of all of these surfaces, get flipped or they're out of order. So you may have to experiment depending on what you're producing. Let's put my angle back to 360. I think mine's okay for the most part, but you could calculate the order. If you notice the shadows are in the wrong areas. Now my light's up here at the top and I'm getting shadows along the bottom edges. That's perfect. That's what we want. But if your light's at the top and you're getting shadows at the top edges, the top surfaces of your geometry, you may want to change the calculate order or just flip the normals themselves. So this is something that just look carefully on your side. All right. Now, one of the great things about working with this screw modifier in conjunction with the path is that the path's edit points, the control points, are still live inside the scene. Now, if I hit the tab key and go back into edit mode, you can see all the control points of the path itself. Now, I had some work I had to do on this control point. I don't want an angle here, okay? Maybe I want it to be a nice little curve. And all of this stuff is still live, which is pretty fantastic. I'm really quite jazzed with this, and I can continue to edit the shape into anything that I want while the screw modifier is still active inside of my scene. So there's a live connection between the location of the points on our path and the screw modifier, which is pretty cool. With that said, I want you to examine for a second here the very tippy top of the model itself. Yeah, see how we have a hole? This hole in the top of our surface has been generated because this point is not perfectly at the center of that x-axis. We didn't snap that point to the grid like we had done on the bottom. If we were to go down to the bottom, check it out. No hole. That's because that point is perfectly in the center of the axis that we swept our object around. Let's go ahead and fix this real fast. Luckily for us, it's an easy fix. Examine our scene from the front. I'm going to go into my snap options, turn it to increment, which is our grid snap, and activate the snapping engine. And simply spacebar G to fire off the move tool. I'm just going to snap that guy right there. Now that that control point is in the center, here's the access line, center of my x-axis, that hole that we had at the top is now in fact gone. So I would redo this entire process, of course, for the pedestal, but this spindle as well. Creating all these really cool profile shapes would be really difficult with our traditional modeling tools that we've learned so far. But with the path system, it's easy, simple, highly editable, and we're always going to get wonderfully smooth, soft curves.